time for a trust. I will continue on Monday. We're gonna have a review today. I will have a review next week on Monday, and the exam is on Wednesday. You cannot hear me? Oh, you had a new machine. But I think that I checked with some people, they were able to listen to what I was saying. Try again or return the new machine. What about now? Can you hear me? Or turn it on. Oh, okay, good, good. Don't return. Oh, okay. The material that we going to cover today is the review material. The review material is already uploaded in Blackboard. So hopefully from the review material, I can cover 12 or 14 pages today. But if you go to Blackboard, this is the problem that you should be looking for. So this is the review material that is in Blackboard. See, you can find. Okay, you're very welcome. Oh, pretty good, Nicole. Getting ready. Okay, we're ready. We only had 28 people in the room, so everybody else is running late. This is the same information that I gave you the other day, and I corrected the mistake about the time. Remember, the exam is a week from today, on Wednesday, and we're going to start at 4 o'clock. You're going to be able to access the question number one at 4 o'clock. By 5 o'clock, you need to upload your answer. It's better to get partial credit than not to get any credit at all. So make sure that you upload question number one by 5 o'clock. You're going to be able to access question number two. And don't forget that question number one has a bonus. Read it carefully. At 5 o'clock, you start question number two. By 6, you need to upload it. I'm not going to take anything that is going to be late. And like I said also before, everything is an open book and open notes, but don't talk to anybody. If somebody asks you for help, say no, and don't ask anybody for help. I forgot to mention to everybody the other day that in this course, the grading is not going to change. It's going to be a letter, A, B, C, probably, I don't know about D's and F, but it's letter. It has not changed. The courses that they had changed to credit, no credit, you can still ask for a letter to be given to you, but we don't have that problem in this course. Also, you already know that all the summer courses are going to be online. We don't know about the fall, but everything in the summer is going to be online. Today, I'm going to start the review. I'm going to continue on Monday also with the review. In Blackboard, you can find the review file. However, I forgot to number the pages. So today is going to be a review, Nicole. Monday also is going to be a review. I'm going to cover influence line for beams, influence line for trusses, deflection rotation for beams, and also for frame. So this is the first problem. Any questions about anything, any clarification, concern before I start? Okay. So I'm going to start now. We have 37 uh, people in the room. The day of the exam, besides you being able to unload it, I will put problem number one in the screen the same way that I'm putting this in here. If you cannot see, tell me, I will increase the scale. I will zoom. So that's what's going in the exam. Uh, I already told you what's going to be in the exam. It's going to be influence line. It's going to be a deflection of a rotation and the bonus and one little bonus. On Monday, if you come early, I'm going to tell you, I'm going to give you more detail, more focus about the exam. So make sure that you are on time on Monday. Any other question? So the day of the exam, besides you being able to download it, I'm going to put it on the screen. I'm also going to put the chat. So if there's any question that you don't understand the exam or whatever, let me know and I will make a clarification for everybody. I need you to turn your camera on during the exam, but your microphone off. If you don't have a camera, don't go and buy any camera. That's okay. I just want to see your face. So the day of the exam, this is going to appear something similar in front of you. And every page, you have to put your name and make sure that you use a black pen, very dark pen, or black pencil or whatever, but make sure I can read whatever you're going to send to me. Read the problem carefully, especially this that show you work. I need to find your work to give you credit. So make sure that you show every detail, everything, every step. I want to see you. And in here, I want the reaction at B, the influence line for the reaction at B. We need to find out what's happening at B when the live load goes across the structure. The live load could go from left to right, right to left. It makes no difference. So one of the questions is the influence line for the reaction. The other one that is always difficult, the shear to the right of B. So just a little bit to B, to the right of B, there is a section, how much the shear changes at this section when the load goes across the structure. And the shear at D. So we need to know at this section what happened with the shear. And the last one is the moment at E. So what I had done, since I need to put the load at A, I also need to put the load at B. To the right of B, I need to put the load. To the left of the hinge, I need to put it. To the left of section D, I need to put the load. And at E, I need to put the load. So I created all of these cases. Even though that some of them, they are obvious. Some of them, they are obvious. This is the one that we need to compute the reaction when the unit load is at A. The second one, this case, when the unit load is at B, is an obvious one. Because when the unit load is at B, we know that the reaction at B is going to be equal to 1. So whenever we have this situation, the reaction at B is going to be equal to 1. And most of the time, I do not work this one. I just show this one on the top. Why do we only put the load to the left of C and D? Okay. We put the load to the left of C because in one, the load in here is going to be 1 and 0. So in one case, it's going to be 1. In the other case, it's going to be 0. We put it only to the left of D because whatever we find in here to the left of D, to the right, going to be 1 minus whatever value we obtain in here. And if you are worried with 1 to the left and to the right, you're going to get exactly the same. So for the shear, we put to the left because the value to the right is going to be 1 minus that value. And I'm going to show it here. So I was saying that this case in here is the easiest one because 1 at B, this is 1. The shear to the right is 0. The reaction is 1. The shear in here is 0. The shear, everything is 0 when this is here with a section of the reaction being 1. I have put another case. This is a section to the right of support B. So I have put it, the unit load obvious to the right, because this is the case that the unit load is to the left. So I'm going to create one just a little bit to the right. And this is the case that was mentioned before. We do just to the left of the hinge because at one time it's going to be 1 and the other one is going to be 0 because the shear here go from 0 to 1 or from 1 to 0. And this is the one that I was saying for the shear at D, we just put one to the left because whatever value we obtain in here, the next one is going to be 1 minus that value. And of course, this is an easy one, the last one, because the unit load is at E. The reaction at E is going to be 1, and there is no more. So I'm going to change the scale, and these are the cases. I never do this one, and I never do this one. I just want you to know. Any question up to this point, feel free. So the reason why we're doing this is because we want to compute the reaction. When we have computed the reaction, we can find anything. By anything, I mean shear at any location, moment at any location, reactions at any location. So we can find anything they ask you or they ask me to find. So these are the loading cases. Now I'm going to take one at a time. The first case, the unit load is at A. So when the unit load is at A, I need to find out the forces in here. I need to find the internal forces. I need to find the forces here at the wall. All of these structures are determinant. For all of these structures, we're going to be able to compute all the reactions. And this is the case. We always break it at the hinge, because at the hinge, the moment is equal to 0. At the hinge, we don't have the moment as unknown. Please turn that microphone off. So I'm going to break it. One free body is going to be this one, and this is going to be the other free body, because the moment at the hinge is 0. You can see this free body that I have in here, A, B, C. The only unknown force is this internal force, what we call the shear. So I have applied moment about this point. I have found that 1 times 10 is equal to 0.5 times 20. So this force, to be in equilibrium, has to go down. Summation of forces in Y, we have 1 and 0.5 going down. The reaction here is 1. And I had computed, since they want the shear to the right of B, I have taken this free body. Look at this free body. I'm taking the free body and I'm doing summation of forces in Y. We have 1 going down and we have 1.5 going up. The shear in here is 0.5 going down. And I'm using this free body. So this shear is positive or negative? Anybody? Look, I'm taking this free body here. I'm computing the shear just to the right of B. Definite is positive. This is positive. And don't forget, both of them, this is the right side of the free body, down positive, left side up. So I was just taking advantage of this free body to check this body. But now I have to transfer this force, equal and opposite. Look, these are internal forces. These forces, we don't see them. We only see these forces when we take our free body. 0.5 that I computed from here, equal and opposite, 0.5. If I do summation of forces in Y, and here I have to go down 0.5, equilibrium. If I apply moment about the wall, 0.5 times this distance, that is 15. This is 15. 0.5 times 15, 7.5. my acting moment goes in this direction, the wall shows one in the opposite. So if you look at my first computation, when one is at A, they want the reaction at B. They want the shear to the right of B, the shear at D, and the moment at E. So when the unit low is at this location, look, the reaction at B, 1.5. The shear to the right of B, 0.5. The moment here at the wall, this moment here at the wall, at E, 7.5. And if you look at where this moment, where is the compression, top or bottom, if you do what I normally do with this, and you bend it. So where is the compression here, top or bottom? Top. So this is going to go on the top whenever you draw the influence line for the moment at E, goes on the top. Look at the shear to the right, or the shear at section D. I'm taking this section in here. I'm taking this section in here just to compute its value. So we have 0.5. They have to go 0.5 down. And based on what we did before, positive or negative? Positive. I have here at the bottom of the page the values that we just computed for the influence line for the reaction at B. When the unit law was at this location, we saw produce 1.5. The shear to the right of B at this location, you told me that was positive and 0.5. The shear at D, you told me that was positive and 0.5. The moment at E, you told me that was 7.5 on the top. So all of these values that you can see in here, all of these values when the unit law is at this location is producing those values. Look. When the unit law is at A, this reaction is 1.5. The shear to the right is 0.5. The shear at D, 0.5. The moment, 7.5. So all that we had done, we found all of this value. With this case. Any question up to this point about that? And you can see it here, the people that answer it correctly. So you need help, you can get in touch with them, but no during the exam. I'm going to this page because this is a case that I never put. But when one is over B, the only value that we had is the reaction at B1. Every other value is 0. Let me show you. This is the influence line for the reaction at B. When the law is at B, this is 1. When the law is at B, look, 0, 0, 0. 0, 0, whatever they ask you when the law is at B, the only value is going to be is the reaction at B1. This is 0. This is 0, and this is 0. So I'm going to go to the next one. one to the left of the hinge. And you go over to the left of C. I imagine you're talking about I think that visual, and you go over left or C. Are you talking about this case? Yes. Okay. Let me answer the other question. I'm going to start this right now. Somebody want to share a point B, and this is leak. The shear at point B. I'm going to go back to the other, but I'm going to do this. I want the influence line for the reaction at B, the shear to the right of B, to the right of B, the shear at D, and the moment at E. So Lick is asking the shear at point B. At point B, we do not have shear. At point B, we only have a reaction. We cannot ask for the shear at B. We need to ask for the reaction at B. We could ask shear to the left of B, or like in this question, the shear to the right of B. So this is B. We want to know the shear to the right of B. So, Lick, what are you asking? I really don't know exactly what you're asking you. There's no shear at B. There's only a reaction at B. But we do have shear to the left. Why do shear at point B has zero value? Okay. And again, there's no shear at B. There is shear to the right of B. I think that you're asking. I think if I'm not getting confused, this is the influence line for the shear to the right of B, and this is zero. Are you asking for that, or you asking for this?
Yes, Professor.
What are you asking?
I'm asking the shear why it go to 0 and go to 1.
Okay, but okay, I'm gonna explain it to you right now. So the question is, this is to the right of B. This is not at B, because at B we only had a reaction. So I'm gonna show you right now. I'm gonna use a clean sheet, and I want everybody to pay attention because this is a very good question. Look, I don't know. This is what I see in my house. I see a huge. It's huge. I don't know what you see in your screen, but this is a section to the right of B, and we want to find the shear at this location. So I'm going to put, because the case that we're looking is this. This is the case that we have right now. When the low is over this support, right? Everything else is going to be zero. If I take this free body, I'm going to take it in here, because it is a good question. So whenever I say take a free body, I'm taking this free body. So this is the same free body, and here I change. And this is one, and this is one. If I do summation of forces in Y, what is this value of the shear in here? 0. Where is the load? Where is this load? This load is at B. This is my influence line, or the shear to the right of me. When the load is at B, the value is 0. So I'm going to go ahead on myself and show you something else. The load have moved to this location, because this is just a little bit to the right of support B. What is this reaction in here? What is that reaction in there? Anybody? When this is just a little bit like 0.0000001, you're right. What is this? Yeah, 1. Because it's 0.999999, I'm going to take the free body. Look at the difference. Before the load was over the support, it was 0. This is my same free body. I'm taking this free body. Does the load one appears on my free body? Does my load appear in the free body? Look, this is my free body. Do I need to put the 1 in there? No. So this is like when I told you in class, you go to international border, you are on the bridge. This is USA, this is Mexico. You already went to a different country. This load is no longer in here. So when I do summation of forces in Y, what is the value of this shear? 1. Positive or negative? Good. So this is the influence line or the shear to right of B. Look, it went from 0 to positive 1. And that is the reason. But this is for a section just to the right of B. Okay. Leak. Do you get it? Leak. Stella. Okay, good. All right. So look, whenever you want me to explain something, stop me, because I want everybody to be clear about it. I want to go back to this. So the first one that I did when the unit load was at 8, and somebody asked me, and I was gonna do it. So we already taken care of this case. Taking care of this, that's obvious. I already did this one because you wanted me to do it. This is the one I'm gonna do now. This is the one, and remember, the first time that we did this, we did it to the left and to the right because you have to see it. You have to become a believer by doing it. After that, you know. But if you still have problems, do both. to the left and to the right. I'm going to do the one to the left. It's obvious that it's to the left. So this is my situation. The unit load to the left of the hinge. I'm going to increase this. Hopefully you can see. To the left. I need to compute the reaction. So since that is to the left, I have to break it always a hinge. If I have 3 hinges or how many hinges, always at the hinge. So this is going to be one of my free body. This is going to be the other free body. When the unit load is to the left of the hinge, and so you can see in here that whenever I break it, so whenever I break it, I have to look at the forces that I have. So at C, I'm going to have a force called Cy. I have to have an equal and opposite. So whenever I break this at the hinge, I have to show this in internal forces equal and opposite. So now I'm going to apply moment about this point. And since both of them, there's no other force, I have to apply moment here because we learned that a long time in statics. I need to get rid of this force. This force times this distance and this force times the same distance. It's obvious that this is going to be 1 because the distances are exactly the same. And if this is 1, this has to be also 1 because internal forces, it gave me equal. This has to be equal and opposite. So now that I know that when I do summation of forces in Y, 1 and 1, what is the value of this reaction? If I have 1 and 1, what is this reaction here? Anybody? 0. So that is gone. Means that when I do summation of forces in Y and here, this is going to be 1. And the moment in there is going to be 1 times 7.5. And so this moment here is 15. But I have a mistake in here. Look, the way I assume this. Look at it. What is my mistake in here? 1 times 15 is 15. What is the mistake that I have in here? Anybody? The moment. The moment is in the wrong direction. I do not have equilibrium because both of them go in the same direction. So the only thing I need to do, reverse it. And that is going to be the direction of the moment. So look, when the unit load is to the left of the hinge, this is 1. If I put the unit load to the right, what is the value that I'm expecting in here? Look, if I, instead of here, I put it in here, what is the value internal I want to find? 0. Because at any location, it has to be equal to 1. I already have 1, the other one has to be 0. Like we did from the shear to the right of B. 0 went to 1. So this is what I have. The unit load is to the left of C, only one load at a time. This can 1 equal and opposite, 1 and 15. So whenever I look at this situation, when the law is at this location, what is the reaction at B? Zero. What is the shear to the right of B? Look at this in my case. The unit load is to the left of the hinge. So my reaction at B is zero. What is the shear to the right of B? Anybody? Shear to the right of B? Zero. And look, the shear at D, the shear, look, I had this free body. One down, one up. The magnitude of the shear is one. Positive or negative? Listen here. Negative, correct. So it's a one. And when the unit load is at this location, look, what is the moment at E? 15. But this moment goes on the top or on the bottom? Look, where is the compression, top or bottom? Where is the compression? Bottom. So now I'm going to go to the influence line. When the unit load is at this location, look, here on the top, the shear B, zero. The shear to the right of B, zero. The shear at D, one. And you told me that was negative. And that was correct. Now, and the moment, look, you told me that was 15. And the bottom, look at the moment here, 15. So all of this came from that. And the last case that I had to do is this one. Shear to the left of D, because whatever value I can find by computation here, the other one is going to be 1 minus that value. So this is the case that I have. In here, my shear force is to the left of this section. So I broke it into two free bodies. And when I break it into two free bodies, I'm supposed to have a reaction here, internal force, internal force. And when I work with this one in here, when I do summations of moment about this point, I'm going to have Cy times the distance 20 equal to 0. Cy times the distance 20 equal to 0. Goes to the right of D, the shear goes to 0. Visual. When the force goes to the right of D, the shear goes to 0. I'm going to show you in a little while, but that's a good observation. Look, let's do this one first. So, look, I apply more on this point. Cy times 25 for a reaction to multiply this and be equal to 0, that means that Cy has to be 0. That's why I killed Cy in here. And I did summation of forces in y, dy is also. This case is where most of the students made a mistake. They put a 1 in here and they put a 1 in here. It's not going to be an equilibrium because you're going to have a moment. So the only way that this could be an equilibrium is this is 0 and this is 0, and this is the proof. So if this is 0 Cy, this has to be also 0 because they have to be equal and opposite. So now I come to here. I have 1, summation of forces in y to be equilibrium 1. Summation of moment, this is 7.5, this moment 7.5. When the unit load is at this location, and I use this free body. We have 1 summation of forces. Look, this is all that I have. This is my free body. This is here. When I do summation of forces in y, this force has to be up and equal to 1. Is it positive or negative? Negative. I'm going to put a negative. And whenever this force is in here, it produces a moment 1 times 7.5, 7.5 going in this way. This moment, where the compression, top or bottom, for this moment? Bottom. So I need to put it on the bottom. We're going to look at this case. Look, when the unit load is at this location, the reaction at B is 0. So look, I'm going to go to B, 0. The shear to the right of B, 0. Look, I'm going to go to the influence line for the shear to the right of B, 0. The shear at this section D is 1 negative. Look, 1. And we always say, whatever we're doing here, if one is 0.2, the other one is 0.8. If this is 0.6, the other one is 0.4. And since this is 1, the other one is going to be 0. So if this is 0, I need to find out what is the value in here. And the value in there is given in this case. When the unit load is at this location, this is 1, and everything else is 0. That's why the influence line from 0 goes to 0. So it was a good observation from B. And look, when the unit load is at this location, the moment 7.5, you told me it was at the bottom. Look, this is 15. This in here is 7.5 because it's exactly the middle. When the unit load is in here, everything is there. Any question about this problem? If you think of another question later, just let me know, email, or I come back to the classroom, just let me know. But all of these problems are solved the same way. Once you get your exam, you read this and find out what I asked. It's like shear to the right of B. We do not have shear at B, only react. There's shear to the right, shear to the left. And always, the unit load is placed at the end, at the support, to the left or the right of the hinge. If we have for a shear, we put to the left because to the right is going to be 1 minus. For the moment, we just put it in here. So all of these are approached the same way. And that's why I put it here. I put the case, the unit load at this location. After that, it moved to B. After that, it moved because we had to the right of B. It just moved to the right because this is at the support. I put one to the left of the hinge. I put one to the left of the section where I want to compute the shear. And I put one at the end. So all of these are the typical locations for the unit. And when I ask you to show you work, this is what I want. I want to see how you did it. I want to see you work. You don't show me your work, you get no point. And here are the answers to what I was asking you to do. I'm going to go to the next problem because nobody's asking questions. If you think your question, you have to let me know. So the day of the exam, question number 2, you will download it from the folder, but I will put question number 2 in the screen. And like I said before, your cameras are going to be on, microphone off, and the chat on so you can ask me questions. In this problem, the vertical deflection at 8. So at this point, the deflection could either be down or could be upward. This is a determinant structure. Everything is determinant right now. So we have 3 unknowns plus 1, 4. We always have 3 equations plus the condition equal to. Whenever we look at this problem, I want to use virtual work. How many sections, how many cuts I had to do to cover the entire structure? 3. 1 in here between A and the reaction. 1 in here between B and C. 1 in here between C and D. Something that you have to remember. When I saw for this, how many forces do I have at C at the hinge? How many internal forces do I have here? But the only force I'm interested is the vertical force because there's no horizontal. So in reality, I have 1 force. So I'm going to put my origin in here because it's going to be force times distance. And here, the moment is going to be that shear force times the distance. And in here, it's going to be the shear force times the distance and 10x, x over 2. And in here, the origin at this location, 50 times x. So whenever you look at this and you break it into sections, you have to determine which one is the easiest way to solve this problem. So I have in here 1, 2, and 3 sections. To solve this problem, I'm going to break it into a free body A, B, C, and C, D. Can I compute By by applying moment about D? Anybody? Can I apply moment about D and find By? Anybody? No. No, because I had a moment in here. I cannot get rid of this moment. So I had to break it into 2 free bodies. Since they want the vertical deflection of A, I'm going to put a unit load at A, my dummy load. So here at the bottom of this page, and this page, I did not include it. I did it after I upload everything because I thought this is easier for you to understand. It will help you to understand the solution that I unit load because it is a vertical deflection. If they want a horizontal deflection, I will put it in here. So I'm going to go back to this problem. Can I have a horizontal deflection for this beam? Can I have a horizontal deflection? Anybody? I want to change it. No. No, because we cannot move this wall. We cannot move it to the right, and the wall cannot. But in the past, I'm given a problem, and people I don't know how, they found a deflection. But this time, I'm not going to trick you. Everything is going to be straight. Believe me. It's a hard time for you, for me, for our family, for everybody. So I'm not gonna do anything that's gonna drive you crazy. I think that you're already crazy. I don't want you to have any problem. So, so whenever we look at this, I'm gonna go back to this drawing. I'll take it like it. So look at this. Vertical deflection. I'm assuming that it's gonna go down, so I put it in. And so this is my dummy, and on the top of the page is the given load. I was telling you before, I had to break it in here. And when I break it in here, I'm going to have CY. I apply moment about this point. I solve for 75. At this summation of forces in Y, I found this. Yeah. I turn for the 75 to here, equal and opposite. Internal forces, we don't see them, but they have to be equal and opposite. I did a summation of forces in Y here. And when I did that, this is also 75. And I didn't put it in there because I don't need it. I didn't put it because I don't need it. But just in case you need it, this is going to be 75 times 15. But I didn't write it in there because I don't need it. Why I don't need it? Because I'm going to put my origin in here. For this section, I put my origin in here. So if I put my origin here, what is the moment in terms of x in here? If I use this free body, I put my origin in here for this section. What is my moment here? 35x. That's why I didn't want to mess. I didn't want to touch this. I just want to point out. So I did compute these reactions, and I didn't compute it because I don't need it. And time is the worst enemy. So 1 second, probably it will help me later. And I did the same in here. I broke it in here. I compute 0.5. Those two, this moment times 10 had to be equal to 0.5 times 20. So they go down and this goes up. 1.5 equal and opposite. I computed this in here just in case. But if I put the origin in here, what is my moment for letter M in terms of X? What is the moment in here? 0.5. Good. So my section So all of these are section 1. Look, section 1, for the dummy load. For the dummy load is also section. I'm going to put the origin because it's easy. Look, for section 1, I'm going to put the origin in here because it's very easy. So I'm going to come here. X. And for section 1 in here, I'm going to do the same. I'm going to put it here my X. Look, I'm going to write it anyway. Now, but what is the moment? The moment in here. What is the moment in here? This is X. What is the moment? 50X, right? So I'm going to, normally I would have written this on top of the structure, but I'm going to take it here and put my free body. Only 1/4, 50. I'm going to come to the bottom, and you already told me what the moment was. I'm going to put it in here. So I had those two. Remember, they have to be assumed in the same direction. They have to be in the same direction. If you put it in the opposite direction, both of them are the same, minus and minus, it becomes plus. So this is good between 0. This is good between 0 and 10. So for both of them, X between 0 and 10. So now I'm going to take my second section. My second section is going to be here. Section 2 and section 2. I'm going to put the origin in here because it's much easier. So this is going to be my origin. X, I have to put the origin at the same location for this one. How do you know which origin is easier? Okay, and that's a very good question. Remember that the moment, if I use this free body, or I use all of this free body, the answer is going to be exactly the same. I had a choice. I put the origin at this location or the origin at this location. The equation here, equation in this region, is only good between 0 and 10. So I can either put my origin here or I put my origin in here. And just include this. Don't you have to put a section which include the reaction at B? No, no, because look, let me ask you a question before I show you why. Look, if I put the origin in here, or I put the origin in here? If I put the origin in here, it's going to be 50x. If I put the origin in here, I have to consider all of this or up to this point. To give me the same equation when I replace the value between 0 and 10, it's going to give me exactly the same value in here. So which is better, to put the origin at this location or the origin at this location? At this location, I have to include all of these forces. Which one visual is easier? Origin here, origin here. Visual. A. Now I'm going to show you something. Look, for this membrane here, for all of this, this is the shape of the moment diagram. This is a straight, the parabola. And we're talking about this point, section 1, right? And physically, I'm going to ask you, look, you are in here and you want to get to this point. You are in here and you want to get to this point, right? So, visual, I don't know, you are 20, I don't remember 30, but you are a young man. So, but look, if you walk from here to get to this point, or you walk all the way to here to get to the same point because the moment is continuing. Which one is easier visual? This one or that one, physically? Right? That's why we move the origin, because the moment, no matter what we do to this point, we can get from here or we can get from there. That's why the second origin, I'm going to put it in here because I don't want to move all the way to this. So this is the reason why we move the origin, because we do not want to work. We are lazy. We want to find the answer the easiest possible way, because time is your worst enemy. But you have to understand this is the reason that there is continuity with the moment. We want to get here fast and safe. We don't want to drift. So, any other question? Am I forgotten? Don't you have to put, how do you know which section include the reaction? No, we don't have to, for the same reason that this point is the same. Okay. So, and worry all the time because I know that you have to go to another class. I have nothing to do, but you do. So now I'm going to look at my second section, section 2.2. I'm going to put the origin here because it's easier to get to this point from here than from. But remember, the influence of all the reactions and all the forces, they're already into this reaction. So this place in here is going to be this one. I'm going to take this free body, and it's good between 0 and 20. Sometimes during the exam, you are so excited, so easy, I'm going to get an 8. And instead of doing the integration between 0 and 20, you do it between 0 and 10. It happens to many of you, or you reverse a force or you forget a force. But look, the integration is going to be x between 0 and 20. I'm going to put the free body. I want to check something. Yeah, and losing some people that are leaving. Let me do the second, please. So this free body 2 is this one. 10x, 75x. Which direction do you want me to assume the moment, large moment here? Which direction? Clockwise or counterclockwise? Anybody? It makes no difference. Tell me which direction you want me to assume large M in here. Look like counterclockwise. The first person. The M. I'm going to put in here the free body for the dummy load. This is the free body for the dummy load. I'm going to put it below. So look, this is my free body. I cut it in here between 0 and 20. Don't worry. So look, I have to assume both of them in the same direction. Doesn't make any difference. If you select this direction for both or the opposite, the answer is exactly the same. I'm going to apply moment about this point because there is a shear force that why I'm using this portion? Because that's all the forces that I have in here. If this were a continuous member, if I didn't have a hinge in here, I cannot do it because there's going to be a moment. So I had to consider everything to the end. If this were one piece without a hinge, I cannot do this. Or I need to find the forces acting here. So here it's very easy because it's only one. So when I apply moment about this point, it's going to be 75 times x minus 10x times x over 2 plus m equal to 0. So I have 75 times x minus 10x, the resultant times x over 2. If this were a triangular load, you have to be careful because of the centroid and other things. But this is uniform. And plus m. So there's nothing easier than this. M is going to be equal to 5x or minus 75x. And to apply moment about this point, leader m is going to be equal to 0.5x. But my question to you is positive or negative? Do I need to put a minus in here? Or this is correct? Correct. Right? So I'm going to multiply these two for my integration between 0 and 20. So what I have left is the last section. I'm going to put section 3.3 in here. So this is section 3.3. And this is section 3.3. So section 3.3, I'm going to take the free body and put it in here. So look, section 3.3 is this one. I put it in here. 75, this is x. So the moment here, 75x. The 4 times the distance. And 75x minus m equal to 0. M is equal to 75x. And here at the bottom, this is my section 3. I'm going to put it in here. The direction of little m has to be the same as large M. So I need to put it in here. But look, M in here, clockwise. What is the problem with this? 0.5x. What is my mistake here? What do I need to put in here to be correct? What am I missing? 0.5x plus n negative. Exactly. So I had covered the entire structure. Section 1, section. But look how easy the moment is in here. 0.5 times x. Look how easy it is in here, 75x. So after that, I came here and did my integration between 0 and 10, 0 and 20, and 0 and 15. I did all of this that you can do in your calculator. And the deflection, look, all of this in here, it came with a minus 25, so it means that goes in the opposite. Any questions about this? Let me tell you something else. Look, all of this we already done. Now we have to do this integration. Right? And if during the exam, some of you had a beautiful calculator, but you don't know how to use it. So sometimes you get to this point, all of this, and you stop because you don't have time, you're going to get partial grade. But you try to solve certain things and you run out of time, you get 0. So remember, you do as much as you can in the exam. Any questions about this problem? On Monday, I'm going to solve this problem. And also, you already had this problem. This is a very interesting problem because the computation of the reaction, this is a determinate thrust. The most difficult part of this is the computation of the reaction. So on Monday, I'm going to go over a thrust. I think I have a frame. I'm going to do as much as I can. But in between, if you have questions, if you are lost about certain things, just get in touch with me. I will help you. The grader does a great job helping people. So don't feel bad. Like I told you, I'm bored, nothing to do in here. I'm ready to help you whenever you want. Any question before we go, because you have another class at 5:15. Hey, Carlos just left, everybody leaving. Okay, well, you're very welcome, and just whatever you need, get in touch with me. Bye-bye.